Hi guys, in this series of videos we'll be looking at energy, work, kinetic energy, gravitational potential energy, and an exam style question.
So let's start by talking about energy. We've already encountered it a bit, but not in all the cases that we could have done. So energy, well, we can store energy in multiple different ways, and you may have heard some of these terms already. So there's kinetic energy, which we came across previously, and that's the energy possessed by a moving body. And we saw the formula for that was a half mv squared. That's EK, that's the energy possessed by a moving body. But there are many other types of energy, so let's just whiz through those now, or at least whiz through a few of them. So there's chemical energy, that's the energy stored in food or batteries or fuel, the kind of energy that you can, for instance, you can eat food and your body breaks that down to produce energy. You can burn fuel to get the energy out of that's locked up in hydrocarbons, etc. You have chemical energy in batteries that you can use to produce a current. There's also heat energy, which is actually kind of kinetic energy, really. Heat is really just the motion of atoms, the motion of tiny particles. They move around more or less depending on how much energy they have, and that's what we experience as heat. But obviously, in our day-to-day, we don't think of heat energy as kinetic energy, so the fire here is a pretty good example of heat energy. You know, if you warm up a body, you've given that a different kind of energy to motion energy, in that you've given it heat energy. It stores its energy in heat, and then you can get that heat by coming into contact with it, or it radiates off the energy in waves, that kind of thing. We'll talk more about that in a later unit. There's also electrical energy. That's the energy stored by charged particles in an electric field. So what I've drawn here, we're going to come across that later on in the A2. These blue dotted lines are equipotentials, and if you are at, this is a positively charged particle. You could think of that like a proton or something. And these lines here, these blue circles, these rings, are equipotentials. And any particle of the same charge on one of those at that kind of distance will have the same energy stored, experience the same force and have the same energy stored. Really, it just means that if you're pushing or pulling around a charged particle in an electric field, then you have to, as we'll see later, expend energy to do that, and so you must be giving the particle energy. So that's another example. There's also gravitational potential energy, which we're going to talk about in this video, and that's the energy stored by raised objects in a gravitational field. And you might think that these sound similar, right? So here we're talking about charged particles in an electric field and then raised objects in a gravitational field. Turns out there's a lot of similarities actually, and we'll talk more about that in a later unit. What I've drawn here, we're imagining this is, the flat Earth.
Hey guys, to continue watching this video and unlock hundreds of other super concise and exam board specific A-level physics videos, just click the Snap Revise smiley face. Join me today, and together let's make A-level physics a walk in the park.